Hello everyone, I am Bharati from Vailtech High Tech, Dr. Rangarajan, Dr. Sagantala Engineering College. My topic is conversion prediction from clickstream, modeling market predictions and customer predictability. Objectives are to convert window shoppers into purchasing customer by repeatedly reminding the customers of the products through repeated advertisements on social media. Abstract. To convert the window shoppers into purchasing customers, it is done by predictions of the market and predictability of customer. It observes customer specific behavior after showing retargeting ads. By providing coupons, we can convert a window shoppers to a purchasing customer. Introduction. It predicts online purchase conversion in a e-commerce site. By understanding user behavior and intent on web existing predictors, leverage the traditional search pattern of entering queries, then clicking on interesting results. However, conversion takes more than one click. Allow the predictors to consider dynamic marketplace mechanism for a deeper predictions of both clicks and purchases. Software requirements are operating system, Windows 7 and above 65-bit. Programming language Python. Framework JDK. Server Tomcat. Database MySQL. Hardware requirements are hard disk 80 GB and above, RAM 4 GB and above, processor P4 and above. Literature survey. Default detecting fraudulent advertisement on a large e-commerce platform. Author Annie Mayer 2017. Problems definition. The success of e-commerce platform strongly depends on the trust that customers have in it. If a platform is a home to the fraudulence, customers are less likely to interact with that platform. Drawbacks. It takes a lot of time to develop a sophisticated set of rules that are tuned to the individual use case. These rules are constantly needed to be updated by these experts, which in turn again takes time. Solution. Using logistic regression to improve the understanding and interpretability of the fraud detection for the customer agents. Proposed model can be easily adjusted to control the number of items that are forwarded to the customer agent. Sequential predictions of social media popularity with deep temporal context network. Problem definition. Understanding and predicting popularity in social media has attracted great attention since it offers opportunity to reverse the individual preference and public attentions from revolutionary social system. Drawbacks. Temporal context is adaptive time series and correlated with the time informations of a predictions target and its previous user photo sequence. The moving partitions strategy is using data from a moving time window recurrently. Solution. Two types of temporal context alignment to learn sequential popularity in short time and long term popularity fluctuation. The technique server a popularity prediction framework for sequential popularity prediction. A neural click model for web search. Problem definition. User browsing behavior in web search is a key to improving web search effectiveness. But the PGM framework structure of the dependency between the events has to be set manually. Drawbacks. User behavior is modeled as a sequence of distributed representations of the user information need and the information consumed by the user during search. Solution. User behavior is gathered directly from the interaction data, circumventing the needs for the predefined set of rules, which are a key ingredients of existing click modules. Topic: Session-based recommendations with concurrent neural networks. Problem definition. Real-life recommenders system often face the problem of having to base the recommendation only on short session-based data instead of a long user histories. Drawbacks. Popularity predicts that always recommends the most popular item of the training set. Ties are broken up using global popularity values. This baseline is stronger in domains with high repetitiveness. Solution. The basic of both deep learning application in recommender systems and session-based recommender in general. Training the network on automatically extract item representation that is built on content of the item itself. Next topic is in-house solution for the RIXS Challenge 2015. Problem definition. Many visitors to these websites or casual users who comes to the site randomly read the content that appears on the sites and eventually either make a purchase or leave the site without having made a purchase. Drawbacks in this is pattern that exists when likely of a purchase in a given click sequence is high. Metadata of the item is not a high quality. For example, only a category of the item which is in place for only 50% of the cases and price in the training data are available. Solution. Large number of features to extract for CIPS since it can't benefit from informations on items from the overall data as well as the single sessions. TCL can be generalized more easily to other problems because of its ability to separate the task into two-step prediction process. The next topic is sparse factorization missions for click-through rate prediction. Problem definition. The factorization mission FM model is designed for better revealing proper combination of basic features. However, the sparsity of the ads transaction data, i.e., a large portion of zero elements, may severely disturb the performance of FM model. Drawbacks are prediction problem as a binary classification task, where a click indicates a positive negative instance. Laplace distribution can be equivalently expressed as a scaled mixture of Gaussian. Solution. Utilizing the highly peaked Laplace distribution in SFM to the model parameter, since Laplace distribution is non-smooth. A distributed implementation of a SFM model on the Spark to deal with large-scale ads data. The next topic is purchase influence mining, identifying top tier items attracting purchase of target item. Problem definition. The association rules mining uses to extract lamented item relationship from transaction logs, but it focuses only on typical transaction logs which have the limited information only compared to the session logs of the e-commerce sites. Drawbacks are the association analysis is based on typical transaction logs that generally contains limited information to the item relationship. By incorporating item-item similarities, recommended systems have been introduced to identify items which will be preferred by individual user. Solution. More complex model to capture and estimate diverse item-item relationships such as visit purchase. We can mine relationship between not only specific items but also item categories. Predicting popularity of online videos using support sector regression is next topic. Problem definitions are factors such as relevance of the video to the final viewers and the relationship between the real world events and the contents are complex and difficult to capture, increasing the difficulty of the popularity prediction. Drawbacks are visual content of the data proves to be insufficient for accurate prediction. Video content exhibits similar heavy-tailed distribution while its popularity is typically measured by the number of views. Solution is vector regression with Gaussian radial basis functions to predict the popularity of the online video content measured as the number of views. Social interaction data can improve the result obtained using only early views evolution data. The next topic is path to purchase, a mutual exciting point process model for online advertising and conversion. Problem definition is conversion rate overemphasizes the effect of the last click and completely ignores the effect of all the previous advertisement clicks, which naturally leads to biased esteem. Drawbacks are display advertisement in underestimated by 15.7%, such as underestimations originates from the fact that although displays advertisements have little direct effect on the purchase conversion, advertisement click could affect the estimation of the conversion effect. Solution is advertisement click may increase the probability of the subsequent clicks through other formats of advertisements, which in turn contributes to the final conversion. This method furnishes a useful tool for internet market to assess the future values of their potential customers and target their marketing effort. The next topic is session-based recommendations with networks. Problem definition is real-life recommender system often face the problem of having to base the recommendation only on short session-based data instead of the long user histories. In this situation, the frequently praised matrix factorization approach are not accurate. Drawbacks are the first performing parameters were then used with a hidden layer of different sizes. Matrix factorization cannot be applied directly to the session-based recommendation because the new sessions do not have the features which are pre-computed. Solution is introducing the session parallel mini batch based output sampling and ranking loose function. Basis of both deep learning application in recommender system and session based recommendation in general. Existing system. E-commerce site focus on understanding if a customer intend to purchase or not by employing the buyer decision process model, extracting purchase factor from the user web logs to estimate the individual conversion, especially in the customer browsing history. Problem definition. Delivering the effective targets and requires an understanding of individual customer predictability. The transition from the last purchase to the following future purchase, such as transition, can identify the influence between the same or a different products for the purchase needs. Propose a system to maximize this conversion, repeatedly reminding customers of product. General purchase pattern for market prediction by using buyer decision process. Impulsive purchase pattern for individual predictions by using ad-click behaviors. Architecture diagram. The user first have to register and then log in into the e-commerce server. The e-commerce servers will display the product. The user views the products and purchases the products. These products click counts will be saved in the module. Then the user have to log into social media and have to register their details in the social media. This module will display the most viewed product as an advertisement on the social media. Module titles: banking application, e-commerce application and user click, social media application, recommendation based on customer predictability. Module description: banking application. User has to create a bank account using their personal details and unique account number will be generated. Account number and PIN number will be sent to user through email. Once the account has been created, bank admin can add amount to the user account. Payment from e-commerce can be made through this bank application. E-commerce application and user click recognition. E-commerce application where user can purchase product as they like based on category. User can select a product and payment has to be done through a bank application. Product click count and time spent on that product will be stored for each user. Social media application. Social media allows you to create and share your photos, stories and videos with the friends and followers you care about. Connect with friends. Recommendation based on customer predictability. In the social media, recommended product will be displayed based on user click and time ratio and purchase history. If user clicks the advertisement for certain counts, he will get a coupon code for the recommended product. UML diagram. Use case diagram. The user can register, log in, search the product, purchase the product. The e-commerce server will add product, recommend products, and maintain the search history. Python server will click, save the click counts, view times, calculate module viewed, display advertisement. Sequence diagram. The user first have to register in the e-commerce server and then can log into the e-commerce server. The user can view the product and purchase the product. The Python server will calculate the click and view time, calculate the most preferred product, and displays the advertisements to the social media. The user can register in the social media, log in the social media, and views the advertisement. Class diagram. Account, city, history, user, cart, product. Tables are added as class diagram. Activity diagram. The user first have to register, log in, search the product, and purchase the product from the recommended product. Python server will calculate the click and view time and displays the advertisements in the social media. Collaboration diagram. First, the user will register their personal details in the e-commerce server and the user can log in. E-commerce server will display the product to the user. The product that are viewed most by the user and purchased by the user are saved in the module. The Python server will calculate the click and view time and calculate the most viewed product. The Python server will display the advertisements on the social media. ER diagram. Accounts entities are ID, total amount, OTP, transfer amount, email. City entities are ID, name, state ID. History attributes ID, user ID, product ID, durations. Cart ID, user ID, product name, count. User ID, F name, S name, gen, phone, email ID, account number, PIN number, address. Product details ID, product ID, category, rating, MRP, and discount. Data table used in this applications are account details. The purpose of account details table is to store the user account detail. City. The purpose of city table used to store the city names. Cart table. The purpose of cart table is to use to add the items to the cart by the user. History. History table stores the durations of the product. Product details. Product detail table is to store the product details. User table. User table is used to store the user details. Data flow diagram. The user can search for the product, view product, and the product details, view time, and purchased product details are stored in the Python server. Based on their click time and view time and search history, the products are recommended as an advertisement to the social media. The user can search product from the product table and register and log in from the user table. The user account's details are stored in the account table. The user product are added to the cart table. The user purchase details are stored in the cart table. The user payment details are stored in the bank table. The user can register and log in using the register table and login table. The user can upload commands, add friends, and display advertisements using command table, user table, and history. The ordered product recommend the products to the user. The ordered product will save the user click count. History tables will save the search history of the user. History tables will also display the advertisements to the user. Product table will create the coupon for the user who viewed the product multiple times. First, the user has to create a bank account. For creating the bank account, the user details will be collected. Personal details: name, gender, date of birth, and nationality. The next is contact details. The user email ID and phone number should be entered. And then address details has to be entered. Now the user has registered the product. Now the user can deposit the cash. This is done by user account number, username, and the amount, and click the credit button. To view the user details balance account, the user account number will be entered in the inquiry box. Now press the inquiry button. The user details will be displayed. Now the user has to register in the e-commerce website. The username, email ID, address, password, contact details, and confirm password are entered in the e-commerce website. Then the user can log in using their email ID and password. E-commerce website will display their product to the user. The product that the user likes will display the details here. Now click the add to cart. To proceed to the payment, click purchase. Now the user has to enter the account number, 4-digit PIN number and one-time password to make the payment. After making the payment, the order will be placed for the product. Now the user can register into the social media account Instagram. To register, the user has to provide their username, first name, surname, email ID, password, and click the sign up button. Using their social media account, they can chat with their friends, like and comments to their post, and follow the friends, post their movements here. The product that are viewed and clicked by the user in the e-commerce website the most will be appear as the advertisements in the social media platform to convert the window purchaser into purchase the item. Conclusion: to infer purchase needs for customer visiting an e-commerce site, recommendation systems also predict purchase possibility for different products. We explore predictability of conversion prediction to selectively override market-based prediction. If a user lacks sufficient information or shows impulsive behavior, our experimental research shows that ad click behavior can be strong evidence of such conversion predictability. Future work. As online shopping become popular, many research efforts focus on predicting a customer purchase conversion on an e-commerce website. Marginal improvements which suggested that their accretion is not effective to reflect each customer predictability pattern. Thank you.